Okay, so trying out some new video recording software, and we'll see how this lesson goes. This is going to be your first lesson in my geometry class, and this lesson today is actually called, and now I can't use the pen tool. Cool, that's amazing. Thank you, Microsoft, for being terrible. Okay, so I think I have my tech issue figured out. Let's see. Yay, I can write on here now. Okay, so what we're going to be talking about in this video and this lesson really quickly is just math logic. Okay, and here's our 5 EQs we're going to answer by the end of this video. Okay, so let's start with the first one. So what are the tools of geometry we'll be using for this year? That's very simple. So we've got physical tools, things like rulers, pencils, obviously, or pens, protractors, obviously paper. Uh, I'll leave it at that for now. I'm kind of brain dead on that one. Okay, logical tools. So there's really only one answer here, and your logical tools are your brain. You could argue, so your brain is logic, logic is your brain, but we're not going to get into all that, at least not on this video. Physically in class we will. Okay, you obviously have algebraic tools, namely algebra and math. And this all comes down basically to formulas and equations. I'm going to abbreviate. No, I'm not. I'll start abbreviating eventually. You'll get used to my shorthand. Okay, and we also are going to be using a whole lot of coordinate planes. Okay, so you've got a one-dimensional coordinate plane where we're talking only about an x-axis, right? And 1, -1. And of course, this goes on and on and on, right, to plus or minus infinity. Okay, and you can also include a second dimension, namely a y-axis now, perpendicular to your x-axis. Okay, and what this one is called here in green, this 2D, is a 2D Cartesian coordinate plane. And that's just your basic XY axis grid that you've been using forever. And this guy over here in blue is what we normally call a number line, and it's only got the one axis. Okay, so this guy here would be a one-dimensional, should be a one-dimensional coordinate plane, and this guy here would be a two-dimensional coordinate plane, right? So those are our tools of geometry, so to speak. Okay, so now let's move on to our second essential question. So what is a conditional statement? So a conditional statement, you've got an example of one, is right here. If it's raining, then it's cloudy outside. Okay, so this first part before the comma, this first part, if and then it's raining, this is called your hypothesis. Okay, we ought to be familiar with that word from science classes. And this second part, after the comma, after the word then, is called our conclusion. Right? So we're first asked to verify the validity, which means tell me if it's true or false. So if you ever see that, that's fancy talk for is it true or false. So we're being asked to verify the validity of this conditional statement. Okay, so this is a statement, but it's a conditional statement, and I'll explain why here in a second. So if it's raining, then it's cloudy outside. Well, obviously, this has to be true, right? It can't be raining and then there's no clouds. Okay, and I know physically in class you guys are going to argue with me endlessly on this, which is fine, but obviously I'm not going to do that in the video. There's nobody here. Anyway, so why is this a conditional statement? A conditional statement is a statement with a hypothesis and conclusion that's only true when a condition is met, right? So in this case, for it to be raining, it has to be cloudy outside. The condition that's met is that it's cloudy outside, right? So if you walk outside, it's raining, and there are in fact clouds, which obviously there would be, right? That is the condition that's met for this whole statement to be true. Okay, so that's what we're getting at there. So moving on, what if we flip the hypothesis and the conclusion, right? So if we did that, okay, now we would have, instead of it's raining, then it's cloudy outside, right? We would have if it's cloudy, and I'm going to skip the word outside, then it's raining. Okay, and we're also asked to verify the validity of this guy. Is it true or false? And obviously I can't spell. Raining, that's just going to bother me. Okay, then it's raining. So is this true or false? Well, we know that this is false. Just because it's cloudy does not mean that it has to be raining. There's plenty of times you walk outside and there's clouds, right? And it's not raining. Okay, so that would be our explanation there. Okay, so in a nutshell, that's what a conditional statement is. And right here on number 2, what we ended up finding, this is the converse. This is called the converse. Think of reverse. This is the converse of our original conditional statement here from number 1. Okay, so when you flip hypothesis and conclusion, you get the converse of a conditional statement. So just a little side note there. So number 3, and this really doesn't apply to the video, but come up with your own true conditional statements whose converses are also true. So I'll give you another example of, let's see if I can even do that real quick on the fly. Okay, got one. So, and this is kind of morbid. If you've a pulse, then you're alive, right? If you've a pulse, then you're alive. If we do the converse of that, so this is true, obviously. I would hope so. Okay, so this is true. If we do the converse of this, so instead of if you've a pulse, then you're alive, we're going to say if you're alive, then you've a pulse. Okay, and this is also true, right? So I came up with a statement that was true, a conditional statement that was true, whose converse was also true. And we'll talk about why that's a thing here in a second. First, let's address EQ3. So EQ3 is asking, what's the difference between mathematical conjectures and theorems, right? So let me give you an example of a conjecture. Okay, so if x is less than y, then, well, no, that's a bad example. I need a third variable, and I'm not going to do that. Let's use numbers. Okay, if x, oops, I'm still using the eraser. If x plus 2 is 7, then x is 5. Okay, so what I have right now, this is a conditional statement. It's a mathematical conditional statement. I haven't proven if it's true or false yet, right? So any conditional statement that has not been proven true is called a conjecture. Right now, this conditional statement is conjecture because it has not been proven true, right? Now, if I go ahead and prove it true, okay, so if I take x plus 2 equals 7, if I solve this equation by just, subtracting 2, x is in fact equal to 5. So that means that this guy is true, right? So when I prove a conjecture true, that makes it, in math, that makes it a theorem. Okay, so this guy here is now a theorem. It has been proven here algebraically beyond any shadow of a doubt. Okay, so that's the difference between conjectures and theorems. Pretty simple there. Okay, so EQ4, what's a biconditional statement? So let's back up. So this example I came up with here, I came up with a true conditional statement whose converse was also true, right? So if you have a pulse, then you're alive. If I flip that into its converse, if you're alive, then you have a pulse, it's still true. So it's true originally and it's true in the converse. That means this guy is a biconditional statement. Okay, so what is a biconditional statement? It's a conditional statement whose, well, let's not say whose just yet. Well, okay, I know a simpler way to word this. I can go ahead and just say it's a true conditional statement. This is why I don't teach English. It's a true conditional statement whose converse is also true. Okay, easy peasy there. All right, and our last EQ. How do we prove a conjecture false? Right? So let's go back to our, whoops, went back too far. Let's go back to this guy right here. If it's raining, then it's cloudy outside. So if it's raining, then it's cloudy, right? And I'm not going to write the whole thing. Okay, and we saw that this is obviously true. It holds true, right? Now, its converse, however, we can prove the converse false, right? So let's pretend the original conjecture was the converse. Let's just say if it's cloudy, then it's raining. Oh my goodness. Okay, well, this is false, right? A counterexample to this. So we prove conjectures false with counter examples. Okay, a counterexample to this is if you walk outside and it's cloudy but not raining, that is a counterexample of this because it proves it false. Okay, so how do we prove conjectures false? We prove them false with counterexamples, right? And we'll get more into that in the lesson practice. Okay, so that is our short little lesson video. Obviously, if you have any questions, shoot me an email or ask me in person, however you want to go about it. Besides that, have a nice day. Goodbye.